Okay, here's quiz for today. I've constructed graphs of functions that you should be able to identify. And I've asked that you make a table, which is ultimately going to be a table with a composite F circle G, or F of G of X. The way you make the table is you evaluate G of X. You write the coordinates of G of X, the coordinates of the construction points. So you just read them off of this graph. Okay, we know, incidentally, this graph is in a 4x4 rectangle. And here's a red dot for this one. Here's a red dot for this one. Both in 4x4 rectangles. And of course, a 4x4 rectangle is a square, but I'm going to continue to call it a rectangle. So you should be able to tell me what the coordinates of the construction points, the points marked with X, are. And you should be able to do that for the G of X function. Then once you get the G of X values, you find F of G of X, not F of X, F of G of X. You take these values and see what the value of F of X is. In most cases, you'll get one of the construction points, but in some cases you won't, you'll have to make estimates. Then, I want you to write the formula for F of G of X, tell me what the domain of F of G of X is, tell me what the range of F of G of X is. All that's something you should be able to do based on the homework to do today. And also based on what you needed to know for the test, which is these graphs. Okay. Okay, now about half the class doesn't know how to construct these graphs, and that's something you've been tested on due to today. Okay. Now, a lot of people did pretty well on the test, and a lot of people shaky, but probably still alive. But if you don't know how to sketch these graphs, you haven't been practicing. Okay. Because everybody was able to sketch them the day after we started. So think about how you're approaching the course. Well, the red dot always has X coordinate 0 and Y coordinate 0. So you immediately know the X equals 0 and Y equals 0 lines if you know where the red dot is. If these are 4x4 rectangles, then it becomes easy once you know where the red dot is, once you know what those lines are, to label it. So if you don't know that about the red dot, again, you simply haven't maintained the knowledge that you once had. So think about how you might be able to do that in the further part of the course. And if you don't know this, you're not going to be able to fill in these tables. So you can go over to here. Now, I wasn't going to give you the formulas because you're supposed to know the formulas. That was on the first section of the text, the formulas for the various functions. But this is y equals 1 over x. This is y equals 2 raised to the x power. Now, that one wasn't really in the first section, but we've used that more than any other, and you would presumably know that. So can you do the formula for F of G of X, the domain of F of G of X, and the range of F of G of X? Those are questions just like questions you had on the homework. Okay, I just commented that it's, you just got to be able to do these graphs and understand what you're seeing and label it quickly. Okay. And the majority of people are missing some of the definitions, like the fact that the red dot is at x equals 0 and y equals 0, and the fact that every time you've seen me do one of these graphs, got a red dot. I draw a dotted line here for x equals 0, unless it's some other point, okay? For the toolkit functions, these are the toolkit functions. And I probably should have said these are the toolkit functions. That's probably somewhat my fault because I didn't give you the coordinates of the red dot. But for these functions, the red dot is at 0, 0, okay? The basic toolkit functions. Okay, so once you know that, most people were okay doing the labels. And then you determine that here's -2, here's -1/2. When x equals -2, g of x is -1/2. For example, here's a line, x equals -2. Here's a line, y equals 0. Here's a line, y equals -1/2. So this is -1/2. F of x, then x is -1, that would be here. This is going to be -1. X equals -1/2, you get -2. They could also use a formula, which I gave you, y equals 1 over x, but I didn't give you that right away, so you might have been on a different track. Okay, x equals 0. It's not in the domain of the function as sketched, and that's a function we're using, okay? Then when x equals 1/2, g of x is 2. When x is 1, g of x is 1. When x is 2, g of x is 1/2. And you get that from this graph. Okay? Now, if I had it to do over, I'd go ahead and give you the boundary lines, because that might have avoided some of the confusion. Okay. Anyhow, what's f of g of x? Now, the point is f of g of x is what? If g of x is -1/2, then f of g of x is f of -1/2. What's f of -1/2? It's the y value when x equals -1/2. So here we've got line x equals -1/2. Well, we've done estimates. And if I did an estimate based on this graph, I'd get y approximately equal to 0.8. Turns out it's actually closer to 0.7, but it's an estimate. So we get I think I saw somebody with an estimate of 3/4. That's a pretty good estimate. It's actually closer than 0.8. Okay. And I saw some other estimates that look pretty good. But again, we're taking this value and plugging it into this function. We take these values and plug it into this graph. We take these values and plug it into this graph. Then we get them when x is -1, we know that y is 1/2. When x is negative, when x is -2, y is 1/4. If we understand this graph, okay? 0 is not in the domain of g of x, so we don't have a number to put into f of g of x, okay? So I'll write that as no g of x value. And you're not going to be able to read that from back there. But the point is, if x isn't in the domain of g of x, we're not going to get a value for f of g of x. And that's something you really need to understand. It's not that that's one of the harder things to understand in the course, the whole domain and range thing for composite functions. Okay. So you're having trouble with it. There's a reason for that. It's not easy. Okay, but keep at it. This exercise is here to give you that idea. Okay. Now we can fill in the rest of the values. If g of x has value 2, f of g of x has value, well, that's going to be up here. It's going to have value 4. If g of x is 1, then f of x is going to have value 2. And if g of x is 1/2, well, let's see, here's x equals 1/2. I'm writing it kind of tiny, but hopefully you can see the line. Here's where we intersect the graph. And it looks like a little closer to 1 than 2, y equals 1.4. Now this number and this number are estimates because you have no idea how to evaluate 2 to the x without using a calculator. Okay, except that values that were like the ones we're using here. So when x is 1/2, what's 2 to the 1/2? Okay, the graph gives you an idea and gives you a good estimate. 1.4 is a good estimate here. 0.8's not a great estimate, but it's okay. Anyhow, we could then draw a graph of f of g of x. Graph rather quickly. Here's y equals 4. Here's y equals 0. Here's x equals 0. X equals 4. And I realized I'm using a different camera. Doesn't do some of the bad things the other one does. But it also has some disadvantages, like it's too low because the tripod isn't high enough. Okay, so here we have this rectangle, which is going to be sufficient for all these f of g of x values. And oh, geez, sorry, the x values go from -2 to 2. If you look, okay, all the y values are between 0 and 4. All the x values are between -2 and 2. So we graph the f of g of x values versus the x values. How are we going to get these x values? Here's x equals 0. Now I'm just going to draw a type 2 graph. So we know that that's -2, -1, -1/2, 0, 1/2, 1, and 2. I'm not going to fill in the numbers. I'm just going to sketch the graph. You should be able to fill in the numbers once you get this graph sketched. So here we got y equals 2, y equals 1. We could go to 1/2. So what points do we get? When x is -2, we get f of g of x is about 0.8. Well, -2.8 is a little less than 1. That's going to give us a point of the graph, maybe about here. When x is -1, g of x is 1/2. Where's 1/2? Halfway between 0 and 1, that will be this line. So when x is -1, y is 1/2. Did I get that right? Yeah, that's 1, that's 1/2. Okay. When x is negative 1/2, y is about 1/4. So that'll be on the lowest construction line. So we get points here. When x equals 0, we don't get anything. Why not? Because we got to go through g of x to get a value to plug into f, to get f of g of x. And there's no value of g of x when x equals 0. Okay, then when x is 1/2, we get a value of 4, so that's way up here. When x is 1, we get a value of 2. And when x is 2, we get a value of 1.4. So it's like we get something like this and then something like this. It's kind of like a reciprocal function, but it's distorted because we've taken the reciprocal values and run them through the exponential function. Okay, that's a composite function. Now, the formula for f of g of x. I think I can't see that. Can I see? I can see this. I have much more here, but I'm using this camera. I think I'm using this camera. Okay, I'm not using that camera. Sorry, this setup's a little bit new. Okay. Okay, to get f of g of x, we start with the definition of f of x, which is 2 to the x. Then we replace x with g of x, and we get f of g of x equals 2 raised to the g of x. And of course, since g of x is 1 over x, this is 2 raised to the 1 over x power. We can see now why 0 isn't going to work. It didn't work here because it wasn't on this graph. But if we define the function in general from other values of x, it's not going to work because we can't do 1 over 0. Division by 0 is not defined. I need to zoom this back a little bit so we can see everything. And I should raise it a little bit, but okay. So that's your formula for f of g of x. Domain of f circle g. And you should know from the open math assignment that that's how you name the function that you get if you do f of g of x. Okay, so f circle g is 2 to the 1 over x. I'm just going to say you got to be able to do you got to be able to find g of x. You got to be able to put x into g of x. G of x is 1 over x. So X can't be zero. Makes sense? If you can't get a value of G of X, you can't calculate F of G of X, just like we saw here. But here it is with formulas. Okay? Back up a little bit. You want to make that statement? Yep. If we go back to the graph as it's shown, the domain of G of X is interval from -1, -2 to -1/2, union the interval from 1/2 to 2, because between -1/2 and 1/2, there are no graph points. So if we're defining this just by the graph that I drew, you can't have X values between -1/2 and +1/2. Now the function 1 over X is defined for any value of X that's not 0. But if we're doing this by the graphs, not only can you not use 0, you can't use any number between -1/2 and +1/2. Okay? If you extend the graph, yeah, well, the complete graph would include every number except 0. The domain would be every number except 0. Okay, so there's your domain of G of X. It is not defined on this domain, okay? Now your exponential function is defined on every number from -2 to 2, according to the graph. So there's no other restriction on the domain. Now, that's all I'm going to say at this point. I could say more, but leave it at that. The range of f of g of x, well, the graph is continuous, so you should be able to read the range off of the graph you get here when you plug these numbers in, okay? And that's all I'm going to say about it right now, because we need to move on and talk about transformations. So you had a lot of questions about domains and ranges on composite functions. They're important. You're going to be tested on them, but they're not going to make or break you, because it's kind of tricky. On a 100-point test, domains and ranges might be worth 4 points. Okay. And there'll be probably a range of difficulty in the questions that involve domain and range. Main thing is being able to get this formula. Okay. And also, if you're given the formula, being able to tell you what the F and G functions are. We can do more examples of that later, but people did fairly well with that on the assignment. Now, there's one thing people didn't do very well with. That's the thing about the bacteria growth. But we're not going to have time to address that today. I'm going to try to address that maybe next time when we have some time. Okay, because we want to talk about transformations. Okay. For transformations are pretty simple. I mean, they're simple to state. They don't seem necessarily easy to apply. I'm going to switch cameras because this other camera actually gives us a sharper picture. I'm just going to have to remember not to write too low on the board. Come down to about and get most of it. Okay. Transformations. This shouldn't come as any surprise to you. Horizontal shift H. Is every point H units. Horizontally. So you got a graph, and this is a point on the graph. It moves H units in the horizontal direction. It's a point on the shifted graph. Now, you know, with the basic toolkit functions, if I ask you to do a function in a 4x4 box where the red dot is at HK, that means that your toolkit function has been shifted H units horizontally and K units vertically. Okay? Every point of the graph has to be shifted by the same amount. So if you get the entire graph, maybe it looks like this, then every point shifts. This point specifically shifts over here, but this point will also shift H units. It'll put it over maybe here, and maybe you're going to have a graph that kind of looks like this. Okay, can you see that this graph is shifted to the right relative to this one? Make sense? And if you take every point here and draw a little arrow this long, it's going to take you to the point on this graph. I'm not going to draw all those points because it confuses the picture. So it is trying to label too much, not enough space. I do that real well, but I think you get the idea. Okay? You're familiar with this, we've been doing it. If you construct a toolkit squaring graph and then shifted H units in the horizontal direction, then it's going to be f of x minus h. It's a toolkit squaring function. X squared would become the quantity x minus h squared. Okay, vertical shift. K. Every point is shifted K units vertically. So again, if we have a graph and a point on the graph, if this is the original point on the f of x graph, this is the corresponding point on the shifted graph. The original point's down here, shifted is up here. So if your graph looks like this, then the shifted graph is going to shift this point up here and take the rest of the graph with it. So it's going to be kind of like this, over here like so. Every point goes up K units. So if this graph is y equals f of x, this graph is y equals f of x plus k. Does that halfway make sense? If you're adding k to the value of f of x, that means you're adding k to the y value. If you add k to the y value, that makes the y value k units greater. So here's your y value, and you add k, here's your new y value. Okay? For the same x. The other one is vertical stretch. Vertical stretch by factor A. Every point moves A times further from the x-axis. And if A is negative, it moves to the opposite side. The x-axis. In other words, it's reflected. Picture that. Draw. So let's say you've got a graph that's constructed in a rectangle. Okay. Might not be one of the graphs that you've learned to construct, just some other graph. And maybe the graph looks something like this. If A is equal to, let's say, 3, then you're going to go 3 times as high. Now, I've already done something like this, but so you should kind of seen this before. Okay. Now you construct a graph 3 times as high. So this is original. No here. Window 3 times as high, and that goes from here all the way up. Well, you make the corresponding points in the graph. This point here is near the top of this rectangle, so you're going to have a point near the top of this one. This point is a little less than halfway up side of this rectangle, so halfway is here. We might have a point here. This point over here is about at the same level, and you just kind of draw the exaggerated shape. It's going to look taller and skinnier, but that's going to be, oh, wait. It didn't look right and it didn't feel right. Okay, again, this point is kind of close to the top of this rectangle, so this point will be kind of close to the top of this one. Probably not that close, but just giving you the general idea. Now, looking at the big rectangle, which goes from here to here, this point is a little less than halfway up the original rectangle. So we're going to go a little less than halfway up the big rectangle. Halfway up the big rectangle is here. A little less than halfway might be about here. So that the graph it looks something like this. Stretched out by factor 3. Does that make sense? Can you see that? So putting it in a window is a good way to see the stretch. But another way to see it is take a point on this graph. Here's how far it is from the x-axis, right? Now, if I draw 2 more arrows of the same length, one up to here and the other up to here. So I've got 3 arrows that represent the y value of this function. 3 arrows, one on top of the other. It's going to tell me the value of this function. So this function is about 3 times as high as this one. Okay. And you can do that for any point. You can do that for this point up here. If I drew a rectangle 3 times as high accurately, and if everything's accurate, then this distance will be repeated 3 times to go from the x-axis up to here. In other words, this point is 3 times as far from the x-axis as this one. Okay. So yeah, I did that there. Just looking at what we said previously. This shift gives you y equals f of x minus h. This is y equals f of x plus k, horizontal shift, the vertical shift. So y equals f of x becomes y equals a f of x. Well, if you put all 3 of them together, okay, we can vertically stretch our function. Then we can move it anywhere we want it. We can shift it h units in the x direction, k units in the y direction. That makes sense? We got to stretch it first. Alpha Math is going to tell you that. So vertical stretch, your y equal original. Y equals f of x. Vertical stretch, y equals a f of x. Horizontal shift, we then do a horizontal shift. We get y equals a f of x minus h. Then a vertical shift. Y equals a times f of x minus h plus k. Those are the rules. Open Math will clarify those videos with the text, with examples. And just apply the rules. The square function. Do something you're familiar with. Okay. So in this picture, I'm going to go back to graphing in rectangles. And I'm not going to do all the construction, but I assume you can do all the construction. Okay, then I'm going to vertically stretch it. I think I've actually already done this, but we're going to do it again. So now we've got this blue rectangle. And if we construct our parabola in the blue rectangle, it's going to get skinnier, right? So we start with y equals x squared. We'll stretch by factor 2. Make this rectangle twice as high as this one. Then our function is y equals 2x squared. So we start f of x equals x squared. In general, we've stretched by factor a. We get f of x is a times whatever the original function was, a times x squared. In this case, the vertical stretch factor was 2, so it's 2 f of x equals 2x squared. So what we have here is the general form of the transformation. Here is a specific example of it. Then I'll put the red dot in here. Then we shift it h units. How far do you want to shift it? I want to shift it all the way over to here. I'm going to take the blue rectangle and I'm going to put it here. Of course, the red dot for the squaring function is still at the base. And our function is constructed inside this rectangle exactly the way this one was. Subdivide it, do the whole construction process. Okay. Now, how far does it look like I shifted it? Show me with your fingers. Here's x equals -2, here's 2. So this is 4 units. How far did we shift from here to here? More than 100? This is 4 units. It's like this. How much is this? So if this is 4 units, this is how many units? Okay, I'm seeing. Well, the number I see most frequently is 8. I saw numbers around that. So let's say we shifted 8 units, right? So we shift 8 units. Okay, well, it's a horizontal shift. That's a f of x minus h equals a times x minus h quantity squared. Now you got to understand f of x notation and the substitution. We'll talk about that. And you've had homework regarding that for a long time. So make sure you got that down. If you don't, ask me, okay? Give you more explanation in one way or another. Okay, so Specifically, that would be 2f of x minus 8. Was 2 times x minus 8 squared. Then we shifted vertically. Well, I'm going to take this thing and I'm going to shift it downward. I'm going to shift it downward to about here. And I'll put a red dot here. There it is. Now, how far did I shift down? If this is an 8-unit shift, how much of a shift is this? Show me your fingers. Is it more than 8 or less than 8? More or less? Did the downward shift here is greater than this or less than? Again, show me, greater or less? Okay, it looks like the lesses have it, but there's one, at least one vote, and maybe some of the other votes. Maybe it looks about the same. Okay, well, let's see. We're out of time, so I'm going to, but okay, that was 30 centimeters. And this is only 20 centimeters. So if your eyes misled you and thought it was about the same, well, it's hard to see that with the rectangles. Anyhow, for 6, you're going to get a f of x minus h plus k equals a times x minus h squared plus k. In this case, it's 2f of x minus h, 8, plus negative 6. And that's going to be 2 times x minus 8 squared minus 6. And that's the graph that we have here. So this one is 2 times x minus 8 squared. And this one is what I wrote down here. Okay, I hope that gives you background to do the homework, which will be due tomorrow evening. Because then we got to go into inverse functions. And there's a little bit of algebra involved with inverse functions, and that might be a little bit daunting. So we've got to spend some time on that Thursday. Okay. Then we'll be done with chapter 1. And then we go into chapter 2, things get easier. There was a question of why this is subtracting 8. Why do you subtract h but add k? You subtract h because to get the y value, let's say at this point, say this is x equals 9, and you get y equals 2. Okay, to get the same y value over here, x would have to be 8 less. Okay, so over here, if you didn't subtract 8 from x, you'd be squaring a much bigger number to get the same y value. If you subtract 8 from these values, you end up squaring the same number here as you do here. So you're compensating for the fact that x is much bigger, but the y values aren't. Subtract x, subtract 8 from x, do the calculation, and give you the same y values you have over here.